Alright, we'll go to the next page and we will do the multi-angle. So we are on page 19 now and we'll do the multi-angle. It's the same thing, solving trig equations, right? So your goal is to get theta by itself, but this is the multi-angle type y. I'll do a couple of problems from this page basically. So why? Because theta, in front of theta there's 4, so it's 4 theta, it's multiple angles, so there's a value b, we talked about it, and you see there's a 2 theta here. Okay, so how do we go about this? So our goal is to get theta by itself, so that my first goal is always to get the term that contains theta. So in this case it is tan theta. Okay, so I'm going to go ahead and write this down because I would like to use a little more space than that's provided. Tan 4 theta equals to -3. Okay, and then I'll remove the other piece of paper and then we will take it from here. Okay, so my goal is to get the term that contains tan 4 theta by itself. That means I'll divide both sides by square root of 3. So I have tan 4 theta equals to -3 over square root of 3. But then I have square root of 3 in the denominator. That means I multiply top and bottom with square root of 3 because on my unit circle, whatever values I have, it's rationalized. So this is -3 square root of 3, right? Everybody got the numerator and the denominator is just 3. And then because square root of 3 times square root of 3 is just 3. And then what happens? You can see things getting cancelled out. So it's just negative square root of 3. Then you're going to ask yourself when, because this is tan, forget about the fact it's 4 theta, but what you're going to ask yourself, at what angle in my unit circle is tan square root of 3? So we know tan theta is square root of 3 at pi by 3, but you want negative. When is tan negative? Tan is negative in this quadrant, also not in this quadrant, this quadrant. So it will be 2 pi by 3 and 5 pi by 3. So I'm going to write that down. So it's saying theta equals to theta equals to 2 pi by 3 and 4 pi by 3. 5 pi by 3. I'm sorry, this is 2 pi by 3. I better write it down before I confuse everybody. This is 5 pi by 3. Those are the two places where tan theta is negative square root of 3. You can look at your unit circle and you'll find out. So instead of saying theta equals to 2 pi by 3 and 5 pi by 3, I have to say 4 theta. And then what else do I have to do? So the new thing that I have to do, because it's multi-angle, I have to add 2 pi k. So 2 pi by 3 plus 2 pi k. I'm sorry, what did I say? I don't know what I'm writing. I was thinking of 4 theta ahead and I just wrote it down. And sorry. Okay, and then 4 theta equals to 5 pi by 3 plus 2 pi k. Alright. Now my goal is to get theta by itself. So I divide both sides by 4 or multiply by 1/4. So they are the same thing. Right? So this becomes theta, which is my sort of getting to my goal. And so you distribute this to both the terms. So 2 pi, so when I multiply these two, 2 pi times 1 is 2 pi, but you have to multiply the denominators 2. 3 times 4 is 12. Plus 2 pi k times 1, and then there's just 4 times 1 is 4. Okay, let's keep going. Let's not simplify for now. For now, let's just keep it, because we're going to make them the same denominator. So it's a little easier if you just keep it as it is. Theta equals distribute. 5 times 1 is 5 pi, and 12 plus 2 pi k over 4. Yeah, yes. Now I have to make them both having the same denominator. So I'll make 12 as my denominator. So which basically means, the reason I do this is because I'm going to substitute for k and I'm adding fractions. So it's better they have the same denominator before I start substituting for k. So basically I multiply top 4 times 3, right? So I multiply top and bottom by 3. I multiply bottom by 3. So basically this makes it 4 times 3 is 12. 4 times 3 is 12. So I get my same denominator. So this is 2 pi by 12 plus 2 times 3 is 6 pi k over 12. So I got my this one. I can simplify these two to have the same denominator, but let's just leave it. We can simplify later. Equals 5 pi by 12 plus 2 times 3 is 6 pi k over 12. And you know that you can simplify this, but we can't simplify this. So let's keep both the sides as the same. For now, let's keep 12 as the denominator. Makes it easier for for us to figure out at what point should I really stop. So when should I stop? Once I start substituting for k, and now I'm ready to start substitute for k. I need to stop when it's less than 2 pi. If 12 is my denominator, 24 pi over 12. I need to stop here. Right? That's how far I go. Okay, let's start with this. So k equals to 0. So I'm going a little fast, not explaining each step because we've already done a page of this. So now you're just following with me. Hopefully you can do this by yourself, but if you're stuck somewhere, you can always watch this. K equals to 0. So when k equals to 0, so this whole term is gone. So theta equals to just 2 pi by 12 and 2 pi by 12. Now I can simplify as pi over 6. So this is one of my solutions. And theta equals to 5 pi by 12. I will write that because this term is gone. So my second solution. Okay, let's keep going. When k equals to 1, theta equals, so these are my two solutions right now. Let's keep going. Theta equals 1. So if it's equal to 1, just 6 pi plus 2 pi is 8 pi. So it's 8 pi over 12 simplifies to 2 pi over 3. Right? They're both factors of 4. So it simplifies to 2 pi over 3. And let's look at the next one. When k, we are still at k equals to 1, right? K equals to 1, 6 pi plus 5 pi, it's 11 pi by 12. Okay, let's keep going. Oh, I'm sorry, you couldn't see that, or maybe you could, I'm not sure. So hopefully you can see. When I substitute for k equals to 1, in these two equations, this is what I got. So these are the equations that I'm using. Let me go ahead and highlight it. Where's my highlighter? I'm not sure where I left my highlighter, but yeah, here we go. So this is the equation that I'm highlighting for theta. Theta equals to this and this. So basically, I'm substituting for k here. K equals to 0, k equals to 1, and we're going to keep going till we reach 24 pi by 12. And then k equals to 2, theta equals to 6 times, let me move the paper up. 6 times 2 is 12, 12 plus 2 is 14. So 14 pi by 12, still less than 24 pi, which I'm going to simplify as 7 pi by 6. And 6 times 2 is 12, 12 plus 5 is 17 pi by 12, still less than 24 pi by 12. Okay, I'm going to take it here. K equals to, I did k equals to 2, now I'm going to take to k equals to 3. And k equals to 3, theta equals to, I'm saying k equals to 3. So 6 times 3 is 18. 18 plus 2 is 20. 20 pi by 12, which simplifies to 10 pi over 6. And this one is going to be 6 times 3. So 6 times 3 is 18. 18 plus 5 is 23 pi over 12. And I think I should stop here. I'm seeing this so close, and anything I go over is going to go over that. So it looks like I have 8 solution, 4 times my original solution, which sort of matches with this, but you shouldn't always go with that. What you need to go is less than 2. So you do have these 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8 solutions. Alright, hopefully you got this. And moving on to the next problem, which is slightly different. Again, you guys can do this, but I do want to do this one because it's got secant theta. So the only difference between this and the previous problems is you all know how to find secant theta's angle because all you have to do is the reciprocal. So I'm going to go ahead and do this one. Sorry, I'm trying to grab a piece of paper where I can write this and we can do the work. Here we go. So now so we did 5. Hopefully you saw the work, and now we're going to do 6. And 6 is 2 square root of 3 secant 2 theta equals to 4. So I would advise you, if we reach a spot where I think you can do, for both of them, actually even 5 I should have told you, hit pause, see if you can do the work yourself, and if you cannot, come back and watch this video, continue with the video, okay? So let's do that, okay? So, having said that, let's do this. This is what I have, problem number 6. So I need to get the term that contains theta by itself, so secant 2 theta equals to 4 over 2 square root of 3. These two simplify to 2 square root of 3. Okay, for now just let's leave it. Do not rationalize the denominator. You know why? Because we're working with secant 2 theta. I don't have secant 2 theta on my unit circle. So what I do is I rewrite this as cosine 2 theta. What is the relationship between cosine and secant? They are reciprocals, but reciprocals of what? Of the ratio. This is the ratio. That's always keep that in mind. It's a reciprocal of the ratio. Adjacent over hypotenuse becomes hypotenuse over adjacent. That is a ratio. So this can be written as square root of 3 over 2. That's why I said don't rationalize it, because when you take the reciprocal automatically, the square root comes in the numerator. So now I want to look at the unit circle. Tell me when is cosine square root of 3 over 2. Square root of, remember, because it's at pi by 6. And it is going to be 11 pi by 6, because this is where it's positive. Cosine is positive. So my 2 theta is going to be, that's it. It's now similar to the other problem. 2 theta is going to be equal to, I already said pi by 6, pi by 6 plus 2 pi k. 2 theta equals to 11 pi by 6 plus 2 pi k. Divide by 2, because your goal is to get theta by 2. Haha, what did I do this for? 2 pi k. And then divide by 2 on both sides, or multiply by half. It's the same thing. Divide by 2, multiply by half. Theta equals to, first this, pi over 12 plus 2 pi k over 2. For now, don't simplify. You can cross them out, but for now, just leave it. Same reason. We can simplify later. Theta. Even if you simplify here, you ultimately will get the same answer. I'm choosing not to simplify right now, but you can simplify and then work with it. And then this becomes 11 pi over 6 times 2 is 12 plus 2 pi k over 2. And then your goal is to, so you already got theta, so you're good. Now you can start substituting for k, but you need to have the same denominator. Multiply top and bottom by 6. Multiply top and bottom by 6. Right? Because so that you'll have the same denominator. Because 2 times 6 will give you 12. Same thing, you're multiplying 2 times 6 will give you 12. Okay. So let's go ahead and write this down. So theta equals to pi by 12. Nothing happens to that, but this becomes 2 pi times 6 is 12 pi k. And this is what you wanted. You wanted them to have the same denominator. And it just happens that the numerator is the same. So because the numerator is the same anyway to start with. Equals 11 pi by 12 plus 6 times 2 is 12 pi k over 12. Now we want to start substituting with k, but you want to keep in mind that theta needs to be less than, again, 12 is the denominator, so 24 pi over 12. Okay, let's keep going. K equals to 0, you always start with k equals to 0. When k equals to 0, this term is gone. So theta equals to pi by 12. This term is gone, 11 pi by 12. So that's one set of solution. Okay, let's keep going. Let's do k equals to 1. Theta equals, k equals to 1 means 12 times 1 is 12. 12 pi plus 1 pi is 13 pi by 12. And here, right? So 12 plus 11 is 22, 23 pi by 12. And what do I notice? I should stop right here because 23 pi by 12 is just about 24 pi by 12, just less than. I can't anyway go greater than that. So I have 4 solutions for my problem number 6. Please follow it and hopefully we got it. And rest of the problems, if you want to do, you can look at the key, which is on Schoology. All the notes key is always in Schoology. You can do more problems. You can try problems from the homework. You can have many more. The only thing I'm leaving out, just because I'm short of time, is where instead of it being it's a fraction. The coefficient of theta is actually a fraction instead of being a whole number. There are 3 such problems, so I'm leaving that. We are not doing that for this year. All right.